Hi there! Welcome back to our second NASA Earth Exchange video tutorial. Today, we're going to use the virtual computer we built last time to learn how to process Landsat data. So by the end of this 20 minutes video tutorial, you should be able to create a beautiful image like this shown on the screen. So let's first go to landsat.usgs.gov. So this is the website that you will find almost all the background information about Landsat data. On the left, click on Product Information and choose Global Land Surveys. And this is the data set we're going to use today. And also on the left, click on Science and choose Landsat 7 Science Data User's Handbook. So this is the online Landsat 7 User's Handbook. It provides very detailed and very useful information how actually we can understand or process Landsat 7 data. Let's see, click Orbit and Coverage. And it describes an orbit and the swath patterns of Landsat data. Let's see, you can choose WRS, which describe the worldwide reference system of Landsat scenes. So basically you can use path and row to locate a Landsat scene. Also, click on Data Products. This is chapter 11. And also click on Level 1G product. Our Global Land Survey dataset is Level 1G product. And here you will find almost all the information we're going to talk today. And for instance, it describes how to convert digital numbers to radians and also from radians to surface reflectance. So I want you to keep these web pages open. And so we're going to come back to these pages later on in the tutorial. So let's open a terminal window and log into the virtual computer we built last time. Oops. And changing to lab 2. So it has 2 shell scripts under it, and the script directory has a Hubangqiao Python script. And the TMP is our scratch space. And at this moment, there's nothing under TMP, but we're going to stage data under it. So type /stage data, hit return. And as you can see, the information printed out on the screen, basically it does is copy the original data from our Landsat repository and actually unzip and untar it into our scratch space TMP. So, see, now we have data under our scratch space. And if you're interested, you can cd into TMP P044 and choose the 7X. That means Landsat 7. And you can see those TIFF files are the actual data file, and the .met or met file is the metadata. So if you're interested, you can take a look at the metadata. Here, it describes all the information about the data set. And for instance, what is the path, what is the row, and the date, those kind of information. If you go down, let's see, L1G, and it also tells you what is the maximum and minimal radiance we're supposed to have from this data set. Go down here, it describes actually the range of the digital numbers, which is from 1 to 255. So basically, that's 1 byte digit number. So we're going to learn how to convert those digital numbers to radians. Close the file, go back to our lab 2. So we're going to use the example 1 shell script to create our first Landsat image. It's better actually to take a look and see what's going on in the script. So as you can tell, actually it's very simple. So it calls a Python script under scripts called Landsat_etm.py to process the Landsat data. You have to read into the meta file and read a whole bunch of information and then start to process the data. Here, the 4 is because the original data set is too big for our free tier virtual computer. So we have to resample the data. Let's say every 4 by 4 pixel, we actually can take only 1 pixel to process. And 0 means we're not going to do the atmospheric correction in this practice. So very simple. The rest of the code is just to do the visualization of the data. We don't have time to go into detail about the visualization, but you can have a look of look into the Python script. So let's run it. Okay. So basically, as you can tell, what it does is just reading in the raw data. Let's see different bands, and you're reading the data TIFF file and try to convert digital number to radians, and then calculating the surface reflectance from the radians and based on some assumptions. So that's what the script does. So we have finished the run, and let's take a look at what is the result. And see right there, so we have created our first Landsat image, the PNG file. So let's take a look and use display and the name of the PNG file. Well, the image is kind of big, so even when we resample the data, it's still kind of big for our free tier virtual computer, so it takes some time to load it. There we go. So right there, okay. Yeah, for most of you, I think this is the first satellite image you've ever created, and it's kind of, even to me, it's kind of exciting because this image is, of course, it's of San Francisco Bay. It was taken on 1999, as shown on the title, and almost 15 years ago. And as you can see, even we actually resample the data to, every 4 by 4 pixel, we took only 1 pixel. It also still shows quite some detail of how the land surface looked like back 15 years ago. And to me, it's beautiful. So we have achieved our goal today to create our first satellite image. But I know some of you will be interested in knowing what the script actually did. So I'll spend some time and walk you through some of the basic of that script. So let's change the directory to scripts. and take a look of Landsat etm.py. So I want you to go down to the main function there. So if you want to, you can actually set the number so we can know. Okay, so if we go to line 293, that's the main function. So the whole main function is, it's actually does one thing. It's just to read the meta file, and read some information, and to verify if the meta file is from Landsat 7 or ETM, and then pass, let's say this is, and pass the information to Landsat ETM. That is the function we're going to look at. So move your cursor to the name of Landsat ETM and hold Shift and hit star at the same time. You will jump to Landsat, which is line 238. So again, here's all the magic. So basically, this function read the metadata and start the loop to process all the bands. So for each band, it read in the TIFF using read geotiff. Yeah, you can take a look at the function by yourself. I don't have time to go to detail into it. And then do converting DN to radians. Now, let's take a look how we do this. And again, move your cursor to the name of function, hit the Shift and start at the same time. So it's a very, very basic, very simple script. So the equation here, just one line, is actually from our the user's handbook. So chapter 11, section 3.1, conversion to radians. So it's exactly the same equation. So that's why I want you to read the handbook. Okay, let's go back to the script and read another one, which is from radians to reflectance. Again, let's go back to the handbook if you like. All the descriptions is used here. What we did is, I want to point out is, well, for this equation, you use the Earth to Sun distance, which we very close to 1 on average. So in our equation, we just use the 1. And also, the ESUN is in this table. It's already given. Also, for the solar zenith angle in degrees, we don't actually have solar zenith angle. What we have from the metadata, if you look like, is the sun elevation angle, which is just 90 degree minus the elevation angle, as you get the zenith angle. So there is a sine or cosine conversion, so you can figure it out. But the whole equation still is from the user's book, the handbook. Okay, so go back to our Landsat ETM function. So basically, after we converting to DN to radians, we skipped a whole bunch of the atmospheric correction code, which we'll discuss later on. And we convert the radians to reflectance based on some Lagrangian assumption. So, but that's it, and just from the user's handbook, so you should read it. That, I believe, conclude, okay, change back. So that concludes our today's tutorial to create our first Landsat 7 image. So congratulations.